Hello and welcome, ladies and gentlemen. We are in Module 1, Topic 2, Packet 2, looking at Activity 2.1 here, quadrilaterals formed using concentric circles. So today, we'll go ahead and just read this word for word here. Let's explore the diagonals of different convex quadrilaterals. If you remember a convex quadrilateral from the getting started, that just means that it is one that's enclosed like this. Both of its diagonals are contained inside of the shape. So here we have, consider the pair of concentric circles with center A, that's the center A right there, diameter BC is shown. So you can see I've already done some drawing here. I did do all the constructions for this activity before the video in order to just save myself some time, because sometimes those constructions can take a long time and these videos can get pretty long, and so in order to kind of avoid that or counteract that, I did the constructions beforehand. I will talk through how to do those, but I won't have to actually do them, which will be nice. So these do ask you to use a piece of patty paper. I'm a dork. I left the patty paper at school and I am here at my house doing these. So I will not have patty paper, which is why the constructions are on here. We'll still be able to look at the shapes and do all of the exercises that they ask us to, but just so you know, these constructions will look different than they would if you did it on patty paper. Okay, so here we go. Use a new piece of patty paper for each quadrilateral. For precision, it is important to use a straight edge when tracing or drawing line segments, which of course I did. So here we go. Draw quadrilateral BDCE by following these steps. So BDCE, you can see up here in this top right, BDCE, there's my quadrilateral that we're talking about, that we're working with here. I've already constructed it. In order to construct it, you had to construct a perpendicular bisector to BC, which is this horizontal line, through point A of the concentric circles. You can see I used my compass. I made my two arcs. I drew my line through those arcs to get that perpendicular bisector. Okay, it says use patty paper to trace BC. Since I'm not using patty paper, I don't have to trace that. Without moving the patty paper, draw diameter DE of the inner circle in such a way that it is not perpendicular or coincident to BC. So I'm drawing diameter DE, so diameter DE of the inner circle. So that's why it's the diameter of the smaller circle instead of the larger one. So diameter DE of the inner circle in such a way that it is not perpendicular, so it's not going to be on this perpendicular bisector that I drew, or coincident to BC. And then it says right here, two line segments are coincident if they lie exactly on top of each other. So basically what this means is my restrictions for the diameter that I'm drawing has to be the diameter of the inner circle. It can't be on this vertical line up and down, and it also can't be on this horizontal line. It can be anywhere else. So I just did a nice diagonal here. You could do your diagonal really close to the perpendicular line if you wanted. You could do it close to the horizontal line if you wanted. You could do it the other way. Okay, your shapes will look different here, but you will be constructing a parallelogram no matter what you do here. Okay, so here we go. What do you notice about BC and DE? So I'm just gonna move this front and center. What do we notice about BC and DE? So BC and DE here, okay? Now there's a couple different things you can notice. Again, I told you these are my favorite problems from the last video. What do you notice? You can notice a lot of things, okay? So one thing that I noticed, you can say that they intersect. They intersect one another, okay? You can say that. You can say they intersect on the inside of the circle, okay? What Carnegie is hoping for you to look, or I guess, I'm getting ahead of myself here. We'll just go ahead and just go along, okay? So A, they intersect. You can say they intersect inside the shape. That kind of goes along with what we talked about. It kind of goes along with what we talked about in the getting started portion, the last video. Okay, so now it says part B, use a ruler to measure the lengths of each side of the quadrilateral. What do you notice? Okay, so I'm going to go ahead, where did I put my straight edge? Right here. Okay, get inches, measure each side. This looks like this side's almost exactly an inch. Oh, whoops, I'm way off center there. Sorry about that. Looks like this side is almost exactly 1 inch. If I go over here, this side is almost exactly the same, also exactly just about 1 inch. This side right here looks like it's about 1.7". The nice thing about this ruler is that each tick is just 1/10, and so if 7 inches was 10, 9, 8, 7, so about 1 7/10. And then if I go over here, okay, also I get 1, and it looks like about 7/10. So said 1 7/10 on this, 1 7/10 on that. I had almost exactly 1 inch on both of those. So I've measured those, okay? So B, use ruler to determine what do you notice. So what do you notice about them? Well, opposite sides are congruent, right? Congruent means they have the same measure. So I have 1 and 1, 1 and 7/10, 1 and 7/10. Opposite sides are congruent here, okay? So now use a protractor to determine whether, or determine the measure of each interior angle of the quadrilateral. What do you notice? I'm grabbing my protractor really fast. Okay, so remember, interior angles are the angles that are on the inside of our quadrilateral, okay? So I'm looking at this angle, this angle, this angle, and this angle. So I want to measure these, okay? So I'm going to go ahead and do that. Oh, geez. And see, this is why this protractor in particular is kind of a beast, because it's really hard to see sometimes if the line is short what the angle is. Okay, so mine looks like this is about 40. Yeah, it looks like I had this being about, 132. I had this being about 132. Okay. And then I'm going to do this other angle right here. I'm going to do angle EBD. Probably could have done this before the video as well to save myself some time, but here we are. Okay. Cool. Sweet. And then, so, there we go. And then that is at, so that's 130. Sorry about this. This is terrible YouTube content. Don't do this. So this one looks like it was about 48. Okay, according to my measurement there. I apologize about that grossness. But if you were to measure these other two, I can tell you that you would get the same things. Okay, whatever you got. And so what did you notice? That should be what you noticed there. The opposite angles are congruent. Okay. So what do we know about BE and DC? Okay. So BE here and DC there. What do we know about them? Okay. I would go ahead and say what we know about them. We could say probably, actually, without any doubt here, we could say that these lines are parallel. Okay. It's just based on the way that we constructed it, based on our angle measures, the opposite angles being equal, based on these two opposite lines being equal. We can say that BE and DC are, in fact, parallel here. Okay. So we can say that they are parallel. Okay. So then what names can be used to describe the quadrilateral BDCE? Explain your reasoning. Write the name of the quadrilateral on the patty paper. So we're just going to go ahead. I'll go ahead and do it up here. Okay, so if you remember the tree, the like family tree of quadrilaterals, and I'll come back to this later so that we don't have to, I don't have to make it multiple times. There's trapezoid, parallelogram. Under parallelogram there was rectangle, rhombus, and then both those was a square. Okay, so starting at the top, we know it's a quadrilateral. Trapezoids have one or more pairs of parallel sides. Parallelograms have two pairs of parallel sides, and then rectangles have all 90-degree angles. Rhombuses have all congruent sides. Squares have all of the above. Okay, so if I'm trying to classify this quadrilateral, I would say that it has one pair of parallel sides. It also, I know these two sides are parallel as well, comparing those. So I would say that it is a trapezoid, at least one pair or more, and also a parallelogram. Okay, trapezoid and parallelogram. Okay, cool. So now on to number 2. Okay, we're going to draw another figure. Use a patty paper to trace BC without moving the patty paper. Draw the diameter FG of the inner circle perpendicular, so just this line up here perpendicular, okay, to BC. Connect the endpoints. Done, done, and done. Okay, so what do you know about BC and FG? Well, it looks like BC and FG are perpendicular to me, okay, and we even said that these two lines are perpendicular. And so I can say without a shadow of a doubt here, I can say that BC and FG are indeed perpendicular. Okay? Cool. So now 2, use a ruler to measure the length of each side of the quadrilateral. What do you notice? Okay, so I'll just measure 1 here. So it looks like 6, so about 1 4/10 of an inch. Okay. And I'm going to, spoiler alert for you, just to save some time, these are all going to be 1 4/10 all the way around. Okay. So what do you notice? All sides are congruent. Perfect. Okay. So now part C, use a protractor to determine the measure of each interior angle of the quadrilateral. What do you notice? Okay. Again, to save time here, you guys, I'm going to hope that you know how to use a protractor. If you don't, ask me for real. I'm not going to like mess around. I'm not going to joke with you, okay? If you don't know how, that's totally okay. They can be tricky sometimes. So ask me if you watch this video and you're unsure. Otherwise, I'm going to save us some time, okay? This angle, let's see, this angle should be 120 if you measure it. This angle should also be 120, and that being this whole entire thing here, not just this little one, okay? This should be 60, and this should also be 60. And if you get slightly different measurements than that, human error happens, it's okay, okay? But these are what you should get if you were to construct this perfectly and get all of your protractor measurements perfect as well, okay? So what do you notice? Again, okay, so I would say that opposite angles are congruent. Okay, you could also say something about how this angle FCG is half as much as CGB, or how GCB is twice as much as GBF. Okay, you could talk about that as well. I think what they're trying to get you to look for here is just that the opposite angles are congruent, same as the last one. Okay, so these two angles are congruent along with those two angles as well. So D, what names can be used to describe this quadrilateral? Again, bringing back the tree from the last one. Okay, we know it's a quadrilateral. So is it a trapezoid or a parallelogram? Well, these sides, okay, because they're all the same length and because they all have these opposite angle measures that are equal. Wow, excuse me. I can say that FC and BG are parallel. I can also say that BF and GC are parallel, which means that it would be both trapezoid and parallelogram, at least one side. So it has two, which is at least one, and then parallelogram, boom. And then we also have all side lengths that are equal. Okay, all sides are congruent. And if you remember, that is the classification for a rhombus. So now our classification, instead of just, so our last one was trapezoid, parallelogram. This one's going to be trapezoid, parallelogram, rhombus. And because we're going to add more and more, I'm just going to start shortening these: trapezoid, parallelogram, rhombus. Okay? Cool. Number 3 says, consider Elijah's statement. What error did Elijah make? So we know he messed up, but we want to know how he messed up. So Elijah says, in the quadrilateral BFCG that I drew, angle BFC, so BFC, so this one, okay, and CGB, this one, okay, are circumscribed angles. So we talked about this in class, the difference between inscribed and circumscribed angles. So if I have inscribed, okay, so this part of a word right here, scribe, okay, if you guys know what a medical scribe is, that means like to write. So that means that something is written, okay, and the prefix in means that it's in something. So if it's an inscribed angle, that means that it is an angle that is written inside of a circle. If it's circumscribed, okay, we can see scribe again, okay, that means it's written, and then circum, this first part, this prefix, means around. So just like the circumference of a circle is the distance around it, if you were to circumnavigate the globe, that would mean that you would navigate around the whole globe, okay? So around, so then an angle that is written around a circle, okay? So these ones are inside of the circles, both of the circles. It's inside the big one, it's inside the little one, okay? And then specifically these angles, right, are inside the little one, or the smaller circle. So it's not circumscribed. And then if you were to have to describe these angles, okay, their vertex is on the small circle and their sides are chords, which if you'll remember is the exact definition of an inscribed angle. So what error did he make? He confused inscribed angles with circumscribed angles. He just got them flip-flopped in his head. If you remember, circumscribed angles have a vertex that's outside of the circle, right? And then its sides are tangent lines. and tangent lines touch a circle exactly one spot. So a circumscribed angle would be like this big one right here, and you can see obviously that BGC and CFB are not those. So those are inscribed on the smaller circle, okay? And then so consider a statement. What error did he make? You can say that he flipped inscribed and circumscribed angles in his head. That's fine. I have to apologize. My printer cut off the top of this this construction right here. Luckily, I was still able to construct the shape, but I wasn't able to get all the instructions. So the first one just says trace BC. So it says trace this diameter right here. And then it says, without moving the patty paper, draw point H where the perpendicular bisector intersects the inner circle. So I have point H where it intersects the inner circle. So the inner circle is the smaller one. H where the perpendicular bisector, that's this up and down line, intersects the inner circle. Boom. Okay. And point J where it intersects the outer circle such that HJ contains point A. So that means that now I need to put point J on the perpendicular bisector where it intercepts the big circle. And then I want to make them in such a way that point A is in between the 2 points. Because if I just followed those directions without having to have A in the middle, I could also have H down here, right? But they said specifically that they want A in between these 2 points, so you can do it this way. You could also have H here at the bottom and then J at the top, but because my circle got cut off there, of course I had to have my H here and my J there. So, and then it says connect the points to draw HJ, so I would just draw this line from J to H here. Because I'm not doing it on the patty paper, I don't have to draw that line. It's kind of hard to see. And then it says connect the endpoints of the line segments to create this quadrilateral. So here is the quadrilateral. So what do we know about BC and HJ? So BC and HJ. Well, they look perpendicular to me, which of course makes sense. It says that this line that H and J are on is the perpendicular bisector, which means that this line HJ is perpendicular to BC. Okay, so that's one thing that I know. Again, for the sake of time, I'm not going to go on and consider more things. But if you have something other than this that's also true, that's fine. If you're unsure if what you noticed is true, you can ask me. We can talk about it. You can ask a classmate. Okay, have those conversations. I know you guys don't necessarily love talking about math, but it is good for you to flex your brain muscles every once in a while. Okay, so B, use a ruler to measure the lengths of each side of the quadrilateral. What do you notice? So use a ruler to measure the lengths, and then what do you notice? Okay, so I will just go ahead and measure 2 here for the sake of time. So this one looks like it's 1 8/10 here, 1 8/10. I can tell you, spoilers, this is also going to be 1 8/10. Okay, and then this top one looks like it is about 1 4/10. And again, spoilers, I can tell you this one will also be 1 4/10 as well. Okay, so use a ruler. What do you notice? So it looks like we have 2 pairs of sides, one pair of sides and another pair of sides. So 2 pairs of sides that are congruent. Right? That looks about right to me because we said that 1 4/10, 1 4/10, right? Those 2 sides are equal. You can mark those with the tick marks. And then 1 8/10 and 1 8/10 are also congruent. So there you go. We can say that we have 2 pairs, so 2 sets of 2 sides that are congruent there. Okay, cool. So now 3, use a protractor to determine the measure of each interior angle of the quadrilateral. What do you notice? Okay, this one, again, for the sake of time, I'm going to not measure these, and I'm going to give you guys a little lesson. Okay, so we can, and you guys can tell this. Okay, so you guys can make this. You can make this inference. You can tell this just by looking at it. But you would want to measure it in your packet. I'm just doing it because the protractor was super awkward to use, and instead of going back and restarting this whole video, I'll just go ahead and talk about it like this. So I can tell you that HBJ, say that this measure was X, right? It was some measure. I can tell you that that's going to be the same as HCJ. So these 2 angle measures are the same, okay? And then H is going to be Y, so it's going to be different from these 2, and that's pretty obvious just looking at them, okay? And then J is going to be different from all of those. Okay, so you're going to have 3 different numbers that you get when you measure these angles. HBJ and HCJ are going to match up. They're going to both be the same. This top angle right here is going to be different from those first 2. most likely smaller, or actually, no, most likely larger than these two, okay? And then Z, this last one is going to be different than all three that you've done so far, and it will probably be your largest angle if I had to guess. If not, it'd be your second largest, okay? And that's just kind of going by my inferences, my brain telling me what's up there, okay? So, yeah, so these two will be the same. So then what do you notice down here? We'd say HBJ and HCJ are congruent, right? And then it says this quadrilateral you drew is a kite. A kite is a quadrilateral with two pairs of equal adjacent sides, so equal, congruent, adjacent, touching sides, which works out, okay, because both of our pairs of sides that have the same length are adjacent, they are touching, okay, so that falls into what we said there. It says if the diagonals of a quadrilateral are perpendicular, non-congruent, and only one bisects the other, it can only be classified as a kite. So this is a lot of classification. So if the diagonals of a quadrilateral are perpendicular, okay, perpendicular, which they are, if they are perpendicular, non-congruent, so if I were to measure the diagonals themselves, non-congruent, so this one is 2.5 inches, this one is less than 2 inches, right? So we can see that those are not congruent. So they're perpendicular, they're not equal in length, and only one bisects the other. So bisection means that it breaks up the line into two perfectly equal parts. So we can tell just by looking, right, that BA is equal to AC in length. Also, we know that this up and down line was the perpendicular bisector of BC, so that makes it easy for us as well. But we can tell pretty easily that from H to A is much shorter than from A to J. So this line BC across does not bisect this up and down line HJ. Okay, so then, and only one bisects the other, then it can only be classified as a kite. Cool. So that is a kite right there, ladies and gentlemen. Also kind of looks like a Star Destroyer if you're a Star Wars fan, which apparently no one in 4th period is. Here we go. So 5, write the name of the quadrilateral on the patty paper. So we can just say kite. Boom. Because the reason it's that simple, okay, it can only be classified as a kite. There you go. So only classified as a kite there. Boom. Cool. So there is that one. So then I believe that is all of 2.2. In fact, it is, or 2.1, excuse me. Okay, so that was activity 2.1, module 1, topic 2, lesson 2, aka packet 2. I hope you all have a wonderful night. I'm sorry that this was a bit of a longer video. I will see you guys in class. Have a good one. Adios.